Okay. So, this is where we ended last day. Right? Why didn't it work? Because right here, when I input -2, because my inputs are the domain, when I input -2, I hit 1, 2 outputs, which means it cannot be a function because you don't know what your result is going to be when you input -2. Does everyone understand? You don't know if you're going to get -1 or -3 as an output. So it can't be a function. It doesn't make any sense. Because a function, like something in manufacture, you put in raw materials and you get out a product. That's what's happening with a function. But in this case, you don't know what's coming out, right? That's why that one didn't work. Now somebody always says, well, what about this spot? That's okay. Why? Because your product, your output, was different. You started with 2, then you started with 3, and they got you different things. Okay? So please pay very special attention to what had to happen for it not to work. Without the picture, your ordered pairs here are what? What is this guy as an ordered pair? -3, +2. Yes? That's okay. I input -3, I got out a 2. Alright? If I throw -3 into the blender, I'm going to get out a number 2 shake. Got it? Now, what's this guy's ordered pair? -2, -1. Yeah? Okay, so I throw -2 into the blender and I get out a -1 shake, yeah? But then Noah comes along and he throws -2 into the blender and he gets out a -3 shake. Why? What? Then James comes along and says, I want a -3 shake. So what do I throw in? A -2. Will he get a -3 shake?
Probably not.
He's got a 50-50 shot. Is that okay? No. That's the problem. So when you write it out, what is the thing that's not allowed to repeat? Y's, X's are not allowed to repeat. Y's can't match up with a repeated X. Okay? Everybody with me? All right. So let's turn the page over. And we get to this thing called the vertical line test. The vertical line test is, again, a very good friend for you, except it only works on graphs. You have to graph it, okay? If you have the graph, no problem. But if you only have ordered pairs, you got to put them on a graph. Everybody cool? And here's how it works. You pass a vertical. Everybody knows what vertical means, yes? I'm just going to draw it anyway in case you don't want to say, because I just saw some people at the back double checking whose names will not be mentioned. That's okay. I didn't name you. I did it on purpose. This is vertical. Okay, you pass a vertical line along the domain. Okay, what's the domain on a graph? Which axis? Right, the x-axis. Okay? If the line hits 2 or more y values, it's not a function. Okay? Everybody with me? So, come back up here. Observe, please. Vertical line, yes? What happens right there if it would stop? Almost got it. Oh, son of a bee. So what happens there? I'm trucking along the x-axis, minding my own business, and then right here I hit 2. So that gives me 2 outputs. That's not allowed. Okay? Will it work not on a graph? Of course not. Right? But it will work on a graph. Everybody cool? So, since this graph is not a function, what is it? A relation. Everybody cool? Alright, so you have 2 jobs with these next 3 little graphs. 1, tell me if it's a function or not, and then list the domain and range. First one is easy. It's exactly like the last example I gave you. So first of all, check if it's a function. Is it graphed?
Yep.
So can you use the vertical line test?
Yep.
Do you have to slide it all the way along, or do you only have to check at certain inputs? Why is it only at certain inputs? Because this is not a line, is it? This is single points. So is there an input between 3 and 2? -3 and -2. I mean, is there an input there? No. So I check here. Am I okay? Function. Function. Oh, what happens at -1? Relation. So this is not a function. Now, list the domain and range. This is the easiest kind of domain and range. The domain is what? The domain is the set of values that make up the independent variable. Yes? That's the mathematical definition of it. What is the functional definition of it? The domain is the x values. Okay? What if it's not graphed as x? Then the domain is the values that are on which axis? The x-axis. So what are the values here? -3. What's the next one? -2. What's the next one? -1. Do I write -1 twice? No, because it's still only one input. Next. 0. Next. 1, 2, 3. And hopefully many of you notice that this is the second time that it screws up as a function. Everybody cool? Now, here's a mistake a lot of kids make. Are these ordered pairs? No, they are not. They are just x values. What did I write first? The smallest x value. Now, when I do my range, will I take the y value that goes with this? No, because I am not looking at ordered pairs. I am looking at the domain and the range. Does everybody understand? So, if in domain I started at the lowest value, where do I start with range? Lowest value. What is it? -2. So my domains I'm going to draw in green. There's 1 at negative 2. Please notice it's not an ordered pair. What's the next one? Negative 1. Why am I only putting dots on the y-axis? Because I'm only caring about the range, and the range is measured on the y-axis. Does everyone understand that? When I cared about the domain, I only looked at the x-axis, didn't I? All right, so what's next? 0. Then what? 1. Then what? 2. Then what? 3. And I have to write them like a set, don't I? Because each of those dots is a single element, right? Everybody cool? Okay. Let's look at the next one. What's different?
There's lines.
It's a solid line. Yeah? So what does that mean for inputs? Is there an input at negative 2.5? Yes, because there's an output at negative 2.5, isn't there? So where does our vertical line have to go? Can it go to single spots? Where does it have to go? The vertical line is checking our inputs, yes? So, how many inputs are there between here and here? 3? Higher. How many inputs are there between here and here? Higher. Say it then. Infinite inputs. Because every single value here has an output, doesn't it? Down to the billionth, the trillionth, right? There's an output. So, but all we got to do is check, does it ever touch the blue line more than once? No. So this is a function. All right? Now, this is where it gets weird. Because it's a line, we always have an input and output, don't we? Because of what I just said, yes? Can I have, as an x value on this graph, 1.137589278? Does that exist? 1.13, oh yeah, it does, because there's an output for it. Picking up what I'm putting down? So since it's infinite, I can have any value that exists on the x-axis, can't I? Does everyone understand that? This is usually where kids start not getting things. So I've been doing my domains in blue. I'm going to do that again. Where does domain live? The x-axis. So if I'm asking you for the domain, I only care about the x-axis, don't I? Where does it start? Where does my x-axis begin with an input? Right there, yes? Where does it end? Positive 3, yes? Cool? Is every number in the middle of there represented? Yes. So my domain is a set of what's the littlest number it can be? Because that's what we got to put first. Negative 3. I've got a dot there. That's where it starts. Negative 3. Can I have every single number now? Is it possible to write every single number? No. So we write that. Negative 3 has to be less than or equal to x, doesn't it? Because negative 3 is the lowest I can go. All my numbers are going to be bigger than negative 3. Why did I put an equal sign there? Who remembers grade 9?
It can be greater or equal.
It can be negative 3. What's the tip-off that makes that negative 3? I'll tell you, it's a physical characteristic of that dot. What? Nope. It comes from grade 9. I'll remind you. Graph that from grade 9. What's the only number that matters? 6. And all the values have to be greater than 6, yes? So we're going to go greater than 6. Is 6 allowed? No, why? Because 6 isn't greater than 6. So what did we do here that made 6.000000000000000000000000001 allowed, but not 6? You circle it, and then what? You don't color it when it's like this. Now what if I do that? Then you color it. Now look at that dot. Is it a solid dot? So is negative 3 included? Yes. So that's why we write it that way. Now what's the biggest I can get? Positive 3. So x has to be less than or equal to positive 3, doesn't it? Right? Now, are there any restrictions on that? Can I be every single decimal and every single fraction and every single irrational number? Can I? I can, can't I? So, there's a restriction. We draw a line. The domain is a set of real numbers, because everything is allowed between there and there. Is everyone cool with that? So now that you've seen it, I want you to try and do the range by yourself, written this way. You can talk to your neighbor. I don't care if you talk a little bit about it. I'm going to shut up and let you think about it for a minute. Draw the range this way. I'll be right back.
Wouldn't the range technically be infinity too? It's also the domain. No, I'm one of those guys. I like to just get around question. I don't even care why it works. I just like to do it. Want to see the creepy font at all? Not really. What's this door stamp? Domain, and then something. That C thing with the line. Oh, it's that thing. D is the... Oh! It's... Is a set. A neutral number. A natural number. The domain is a set. No. It's the E thing is a set. Yeah, I know. So I said domain is a set of range.
go, honey, I'm home. Who's got the answer?
Me and no.
You and Noah? No? What's Parveen?
It has to be less than or equal to -2.
Negative 2 is less than or equal to
3.
y.
And then it has to be less than or equal to
3. Why is it 3? The graph goes to here. Because we only care about the y-axis when we're doing range. Is there a restriction? What is the range a set of? Real numbers. Everybody cool? Kobe. Because sometimes it's not like that. Pardon me? Domain is a set of real numbers, meaning it's everything. Irrationals, rationals, everything. Let me give you an example of when you wouldn't have real numbers. Pay. Can you be paid the square root of 2? No. You're paid by, at best, the quarter hour, yes? So you could never have a pay that was between the values of quarter hours, could you? If I'm paid $10 an hour, then I can only be paid in increments of $2.50, yes? I would never be paid $3.75. Picking up what I'm putting down? That's what I mean by restrictions. Does everybody understand? If a value can't exist, you would have a restriction here. What if we were clocking how long it takes Noah to run a 3,000 meter race?
12 minutes.
Would we need negative numbers?
Well, it does.
Would we need negative numbers? Why?
Considering how long it takes.
You're calculating how long it takes. There's no negative time unless you have a 1985 DeLorean that can go 88 miles an hour and has a plutonium-powered reactor core and a flux capacitor. Somebody gets that joke, right?
Back in the future.
Thank you. Also, he's traveling a distance, isn't he?
Yeah.
He's traveling 3,000 meters, so there would be no negatives. So what would my restrictions be? The domain would have to equal natural numbers, because you can't have any negatives. Understand? Hannah, you had your hand up. What would you write instead? Yeah. For your guys' level, we don't care too much. It'll come into play later. But I'm warning you, because you're going to see that. Okay? Now, this, ladies and gentlemen, is what we call set notation again. Now, it's ugly and cumbersome, right? It's big. I don't like it. Math guys are lazy sacks of poop. Okay? Math guys have invented a shorter way of doing this. So what we're going to do with C is I'm going to ask you, and notice I haven't told you yet, what do you think is the domain for this and the range for this? Try to write it in set notation. Don't worry about the restrictions. Just try to get the numbers and the greater than and less than signs, okay? What's weird about it? Why is it not easy? There's two separate lines, which means there must be what? Two domains. Because there is no input between where and where. There's no input there because, as you can see, there is no output there. Everybody understand? So you must need to write how many domains? 2. What would where do we look for domain? X-axis only. So there is the first one, yes?
Yeah.
So what would it be? Negative 30. Oh, I didn't fool anybody. Is negative 30 part of it? So it's an equals, yeah? Then x. What does that go to? Is negative 10 part of it? No, so it's just that arrow. Negative 10. Everyone agree? That's one set, yes?
Yep. Now
we use this symbol, a U. Does anybody know what that stands for?
Uranium.
It does, indeed. But in math it stands for union, because these two sets are together. So now we got to start the second one, which starts here at what value? 0. Is 0 included? Yeah, sure, you betcha. X. And it goes up to what? 30. Is 30 included? No. So we have it as that. And now the set is done. Everybody cool? Cool? Cool, cool? Cool, cool, cool? George.
Cool.
What do you mean by negative 20 and 30 included?
They've got an open circle, so we don't get to 30. Okay, we get to 29.9999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999 on a graph. Okay? Cool? Cool, cool, cool? Great. Do the R. R. Parveen. Yes.
That was funny. Wasn't that
Where's the only place I look to do the range?
divide?
The x-axis.
Y-axis.
The y-axis. And I go up to there. So what does it start at? Negative 20. Is negative 20 included?
Yes.
Yeah, sure, you betcha. Up to what?
0.
0. Is 0 included? No. Then I have a union because it starts again where? At 10. Is 10 included? No. And it goes up to?
Which is included.
Up to 30. Is 30 included?
Yes.
Yes. Everybody cool? Now, that's big and ugly, yeah? So, math guys, this is set notation. Math guys invented something that you can use when you have a line. Please highlight line. This only works if there's a line on the graph, and it only works where that line exists. Now, is this, if I graphed an oval, is that a line on the graph? Yes, so you could use this. It's not necessarily a line. Okay, the only time it doesn't work, what I'm about to show you, is if I have a bunch of dots. Then you're not allowed to use what I'm about to show you. Okay? Everybody with me? Here's what the math guys do. They do what is called interval notation. And interval notation is exactly the same. It uses these brackets and it uses parentheses. Okay? These brackets are included. These brackets are excluded. And we only care about the interval. So read this first section here. What is the lowest value of domain that we have? Negative 30. Is it included? Yes. So we put a square bracket and negative 30. Because negative 30 is included. Everybody cool? Where does that interval go up to? Negative 10. Is negative 10 included? No. So we write 10 with a round bracket. A parenthesis. Okay?
So you don't even have to.
You don't have to worry about the greater thans, less thans, equals, nothing.
Well, then what would you fill in?
I'm about to show you. We union with what's this side. Is 0 included? So what bracket is it?
Square.
Square, 0, up to what?
30.
Is 30 included?
No.
Round bracket. Everybody cool? So you guys do that for range now. Somebody talk to me.
Big
Square bracket.
thing.
Negative 20, comma, 0, round bracket, parenthesis, anything. Union with round bracket, it's not included,
And then
10, comma, 30,
square.
square bracket. Everybody got it? That's the first wrinkle. Is it smoothed over? Are we cool? I will ask you to do both. You must be able to do both. Now, let's look at the next one. Is this a function? First of all, is it graphed? Yeah, so can we use the vertical line test? Great, let's check. Oh, that didn't show up very well. Gray on gray, you dummy. Shut up! Is that okay? Is that okay? Is that okay? Is that okay? Is that okay?
No.
Look closely. Why?
Because one's closed, one's...
Because that's an open circle. So does that value exist in two places? Where's the only place it exists? That one. Okay? So this is what we call a step function. And this, for example, is how BC Hydro charges you money. If you use a certain amount of power, they charge you. If you go over that, they charge you more. When you get up to a certain level, they bump you up and they charge you more. Till you get to another level and they charge you more. Okay? It's also how phones used to work. But they don't do it anymore because everybody just has unlimited everything except data. Unless you live in America where you get unlimited data, which doesn't really help you because American networks are so bad. No matter what Verizon tells you. They all stink. Everybody cool with this? Alright, now it's tricky. It's very, very tricky. Do the domain first. Where's the only place you have to look? X-axis. I start here, and I go all the way along. Input, 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 input. Weird thing happens here, but there is an input. Okay. Then I carry on. Then I carry on to there. Yeah? So this one, I want you to write both ways. Set notation, don't worry about the restrictions, and interval notation. I don't care which one you do first. Go. I'm going to go set notation first. What's the lowest value? Negative 6. Is it included? I'm just going to keep staring at you till you decide.
It's excluded.
It's excluded. So negative 6, x, And what's the highest value? No. Positive 6. Is positive 6 included? Yes. Does everybody see why that's so? As soon as I hit 3, I jump up to here. At negative 3, I'm here. But at negative 3.000000001, I'm up here. It's an immediate switch. Now, in reality, can that happen? No, there has to be a value change, yeah? But in math, it can. Okay? So, there we go. Now put it in interval notation.
Circle bracket.
Circle.
Negative 6.
Negative 6.
6.
6.
Square bracket.
Square bracket. Done.
Yay.
Easy peasy lemon squeezy. Now, there's only one way that you can write range. Why? James.
Because they have like the open and the close on the y-axis.
You're only looking at the y-axis, right? And there's there. And then is there anything in here? There's there. Is there anything in here? There's there. So what are my only values allowed for range? 3, 6, 9. There is no interval, is there? So can I use this? No, because it isn't between negative 6 and 6. It's only 3, 6, and 9. So how do I write that? You've already done it in these notes. 3, 6, 9. Done. It can't be an interval because it isn't an interval. Right? James was exactly halfway there. You're only looking at the y-axis. Right? He was exactly right. And he knew it had something to do with the y values. That he was seduced by the open and closed dots. Right? How many people were looking at those open and closed dots and had them in their thinking? I bet a lot of you. James, thank you for having the spine to go for it. Does everybody see why the open and closed dots do not matter? Now, what if this dot was over here and they were connected? What would you then have to do with the range here? You would have to consider that. This one isn't connected, so it would stay as a 9 on the end all by itself. Everybody see that? It's tricky until you think about it. Because you gotta remember, I'm only looking at the range. Okay? Everybody good? How would you write this red one? If it was connected, well, we would start at 3, yes. And 3 was included because this line's all the way along, yeah. So it would be 3 less than or equal to y up to and including 6, right? And then union with 9. Cool?
What if the...
And if you were to do it in interval notation, square bracket 3, 6, union 9. Because 9 is the only value left. Everybody good? Okay. Now, you should have some blank space at the bottom right now. Noah has drawn the devil.
No, it's a pig.
It's a pig with horns.
Sure. That's nice.
It looks a lot like the beast that Iron Maiden brought out for the song Number of the Beast at the end of their concert.
It's Iron Man. I had to. It's Iron Man.
Okay, everybody draw
A pig.
a Cartesian plane with X and Y, right? We all know this, yeah? Now, in grade 9, you drew lines on this, right? Okay? Now this line goes from where to where? Infinity to infinity in both directions, yes? So what is this black line's domain? Will it hit every x value? Yes. Will it ever get to infinity? No. So can infinity be included? No. So this guy is round bracket, negative infinity, positive infinity for domain. Cool? What's his range? What's his range? Negative infinity to positive infinity. Everybody cool? Easy peasy, yeah?
Why didn't we do that for the other one?
Because the other ones didn't have lines. They ended. They didn't have arrows. Cool? Everybody good? Now, is this a real life situation? No, of course not. In real life, we have zeros, yes? Right? Noah running on the track. Can't be negative. Cool? So in real life, it might look something like this. So what would this guy's domain be? 0. Is 0 included? Yes. Yeah. So square bracket 0 to what? Positive infinity. Will it get there? Nope. What's his range? Oh, I guess I need to give you a value. There. What's his range? Is 10 included? To what? Positive infinity. Which again is not a real life situation, yeah? Everybody cool? What tells you you're going to infinity? Arrows. Or Buzz Lightyear. You took my joke earlier. You said it quietly enough, I don't think everyone heard, so I'm taking it back. I wait for this to say to infinity and beyond. That's okay, Najee. You just ruined my birthday. Oh. Just kidding. Oh! My daughter made me a card. My son tells the horrible joke, what do you call a magic owl?
Classic.
Houdini! My son thinks that's the greatest joke ever. He's made up a million jokes to go with it. What do you call a magic cow? Moodini, right? I've done this with you guys, right? What do you call an owl that has political aspirations? Justin Hudo, right? He's done a ton of them. So my daughter hates the joke. She hates it. She gets angry. We were at a concert and there was something wrong with the sound, and one of the guys says, hey, any of you guys know some good jokes? And I said, I do! And the guy brings him up on stage. What do you call a magic owl? My daughter's in the audience. Right? She hates the joke. So my daughter gives me a homemade birthday card today. She says, who's the greatest dad in the world? And I open it up. Houdini! And it's a drawing of an owl with glasses and hair like mine. I know, it's so awesome. Mostly because she hates the joke. So, everybody good? Everyone thinks they're okay? Okay. So I'm going to stop recording.